Hi there and welcome to Activity 2 in the Year 8 course. In this activity we're going to be looking at particle theory. Now, when we looked at the previous activity we came up with the idea, or we came up with the understanding, that all material can be set up in three forms. We've got solids, liquids and gases. But the question is, what makes them a solid, what makes them a liquid, what makes them a gas? And the answer for this really comes down under the particle theory model. So, in order to understand how material exists in solid, liquids and gases, we need to talk about the energy. The energy involved that is present in each particle. Now, these three pictures that you can see here demonstrate the three models that we've got. Now, the first one looks at a solid. Now, you can see in the solid they're regimented, i.e. the particles are all lined up. They're touching each other, which means that there's not a lot of movement that can occur. Now, the particles are generally held in place with chemical bonds, and these chemical bonds can be really, really tough, or they can be really, really hard. Really, really soft. And as a result, this is why some materials can be solid, but they might be a little bit more plasticky. You might be able to mold them, etc., whereas some are really, really tough and you just can't break them. So the key thing to understand is that these particles are vibrating. So you can imagine if you've got somebody shoulder to shoulder, they're just vibrating very, very slowly against each other. As we heat an object up, what you'll find is that this vibrational energy will increase. Now, if it increases to a certain amount, what will happen is the bonds between them will become fairly elastic. They won't necessarily break. In some cases they will break, but in a lot of cases they become fairly elastic, and this gives rise to the second diagram. Now you can see in the second diagram, the one in the middle, that the particles are still same number of particles, but they're now less organized. They're all a bit higgledy-piggledy. There are more gaps in between them. They have a fluid movement, and as a result we call this a liquid. Now the liquids have the ability to slide over because these bonds are fairly elastic. They have the ability to pull apart, and it's because the energy within the particles is a lot greater. They're really vibrating a lot and they're bouncing into their particles and they're spreading out. So they have the ability to slide over each other, which gives this liquid the fluid movement. So they've got more energy than a solid, but they are not at the point yet where they can go off in their own free way. So the idea being that we've got the solid, very, very rigid, not much energy. Liquid, yes, we've got a little bit more energy, but the bonds can't be broken. And then finally, what will happen is if they're given enough energy, the bonds will break and it will turn into a gas. Now in a gas, what we get is the bonds are completely broken and the particles have enough energy to break away from each other. The other key thing to understand is that when a substance turns into a gas, the particles move away randomly. There is no order, there's no structure as to where they go. They collide with other particles of the same material, or they may collide with the sides of a container or a wall, etc., etc. But the thing is, they're random. So we go from solid, little energy, liquid, little bit more energy, and gas, huge amounts of energy. And there are specific points at which a solid will turn into a liquid will then turn into a gas. Now, obviously, the faster a particle moves, the more energy it's given. So by heating up a particle, we can actually make it faster, and as a result, we can change it into a liquid. And we'll look at that in the next activity. Also, if we take energy away, as in we cool it down, we have the ability that we can change a liquid into a solid, or a gas into a liquid, because we cause the particles to congregate together. A good way of basically trying to model this is if you think about an assembly. In an assembly, you're sitting in rows, you're a bit like a solid structure, and you're not allowed to move. You may fidget a wee bit, but there's not a huge amount of movement that happens in the assembly when the assembly is going on. As soon as you're dismissed, you go out through the doors and there's a little bit more fluid. You're still in close contact with your partner, but you're able to move in front of them or behind them. So as a result, you're in that liquid form. You've got a little bit more energy. And then finally, you're in a gas. So when you actually leave the building, everybody goes out and they go out in their separate ways. There's a random movement. You spread yourselves out, and obviously if you bounce into the wall, you're going to rebound and keep on going. So really you're mimicking a gas. Now, during our course, what we did, we looked at a variety of different models. Now, if you remember, here's the model that you made for the solid. Now you can see that the particles are held rigidly. Now they will be vibrating. The bonds, the sticks are making the bonds. Now these bonds can be, as I say, very, very hard or very, very soft, depending on the material that you've got. But they're held in an organized pattern. You can see here that we've got our pattern in layers. In this case, it happens to be in a sort of star shape. Now, different materials will have different structures. Now, if I gave this a lot more energy, what would happen is it would turn into a liquid. Now, in this case, the beans inside the beaker here basically show the liquid. Now, as I move the beans across, you can see they're still in close contact with each other, but the result is they've got a little bit more energy. Okay, they're able to flow down. So here we've got a nice fluid movement, and they can move all over the place, but the result is they're still in contact with each other. And final model that we looked at was where we had the balloon. Now inside the balloon, if you remember, we had some marbles. Difficult to see here, but if we bounce the balloon up and down, you can hear the marbles occasionally bouncing into each other as they collide. Now, this is random. I have no idea where those marbles are going to be bouncing, but they'll bounce off the container of the balloon, they'll bounce off the each of the other particles which are in there, so it's random. Obviously I'm giving the energy to get them moving, but there's a lot more energy that I'm putting in here than I was putting in with respect to our liquid model. Okay, so the things I want you to understand with respect to solids, liquids and gases: 1. Solids, not much energy, they vibrate, they're held tightly and organized. 2. Liquids are basically got more energy, they have the ability to flow over each other, but the bonds are still in contact. Finally, 3. Lots more energy, and the particles can move around randomly. They separate off and they collide with each other. Okay, so I hope that explains particle theory. Join me for the next activity, and we should be looking at what happens when you change state, and we'll be looking at this in relation to a graphical analysis. Thanks for watching.